we start a new chapter, Chapter 3, Electric Flux Density, Gauss's Law and Divergence. Today I'm talking about electric flux density. Before starting electric flux density, we need to define electric flux. Electric flux quantity was discovered by Faraday's experiment. So what is Faraday's experiment? First, we prepare the upper sphere, and was given a non-positive charges. So we assume 10 positive charge exists on the surface of inner sphere. And second is hemisphere was put around the charged sphere with dielectric material between them. We have upper sphere with 10 positive charge. 10 positive charges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we also have hemispheres around the upper sphere. Upper sphere surrounded by hemisphere with a dielectric material, so-called, this is dielectric, with permittivity epsilon 1. The next is outer sphere was discharged by connecting it momentarily to ground. We have in upper sphere, and there are 10 positive charge on the surface of inner sphere, and hemisphere around the inner sphere. There may be some negative charge on the surface of outer sphere, so we need to eliminate these negative charges by connecting ground temporarily, and this negative charge going to ground, and after disconnect the ground, there are no negative charge on the surface of outer sphere. So next is the outer sphere was separated carefully. Outer sphere is separated by carefully. The outer sphere with the material permittivity epsilon 1. And of course there are no negative charge on the surface of outer sphere, but surprisingly we can discover negative charge on the surface of the outer sphere. This is like a magic. We confirm there are no negative charge on the surface of the outer surface by connecting the grounding. But after separate this outer sphere, we have discovered 10 negative charges on the sphere on the surface of outer sphere. That this is odd, and this is like a magic. So we change this dielectric material and so-called dielectric material epsilon 2. We perform same experiment from 1 to 4. The result is the same. 5, 6, 7, 8, 9, 10. So it means this negative charge induced not due to the dielectric material. So we may think some streamline from positive charge to negative charge. This is, we have inner surface plus charge 5, 6, 7, 8, 9, 10, and we have a hemisphere, and it means negative charge induced on the surface of outer sphere. So we consider streamline. Streamline exists from positive charge to negative charge. This streamline is called electric flux. 5, 6, 7, 8, 9, 10. We have 10 streamlines. This streamline is electric flux is expressed by psi, and this is same as the charge quantity. This is electric flux. Summarizing, the main question is how negative charge what occurred on the surface of outer sphere. So we can assume some streamline from positive charge to negative charge. This is called electric flux. So we have to consider streamline from positive charge to negative charge. This streamline is called displacement flux or electric flux. Also, same quantity of negative charge are created on surface of outer sphere. One electric charge matched to one streamline. One electric charge match one streamline. One electric charge, one streamline. So the charge quantity is equal to the electric field. The unit is Coulomb. So we are ready to discuss electric flux density. The electric flux density, so-called displacement density or displacement flux density, is electric flux per square meter. So this is psi over area. I take an example. In region 1, we found electric flux, this electric flux, 3 electric flux. In region 2, we found also 3 electric flux. In region 1 and in region 2, electric flux quantity is same. Electric quantity is 3, but electric flux density is different. For this area, we have 3 electric flux. For this area, we have only 1 electric flux. The electric flux density is great in region 1. Electric flux density in region 1 greater than electric flux density in region 2. So electric flux density means is the measure how strong the electric field is. So electric flux density is proportional to electric field. So the relation is electric flux density is electric field, and the proportionality constant epsilon 0 permittivity. This is free space in homogeneous media. And we have 2 methods to find electric flux density. First method is find electric flux and electric flux divided by area. And second method, we find electric field, and by using electric field we can find electric flux density. This is the 2 methods to find electric flux density. Electric flux density is Q is psi over, this is area of sphere. AR is outward on the surface of the sphere. So we have already known electric field by sphere, and electric flux density is epsilon 0 multiplied electric field. So this is Q over 4 pi r square AR vector. So we take an example. The inner sphere radius is A. Inner sphere radius is A, and outer sphere radius is B. We consider full sphere and radius is B. And the plus Q Coulomb are on the surface of inner sphere, and the same quantity of negative charge on the surface of outer sphere. So electric flux is the same, but electric flux density is not same. So this is B. The electric flux density of inner sphere is psi. Electric flux over the area, the surface area, is 4 pi a square AR. This is psi over 4 pi a square. Psi is Q, a square AR vector. dB vector is psi over the surface area of sphere with the radius b is 4 pi b square AR vector. This is q over 4 pi b square AR vector. This is different. So electric flux density of sphere with radius a is greater than electric flux density of the sphere with radius b. Next, we take an example. The first example is 60 nanocoulomb point charge at the origin. Find total electric flux. We have the sphere, and this is sphere, and the point charge is located at origin. The quantity is 60 nanocoulomb. So we have to find electric flux. Electric flux is the psi, is the Q. At this case, the electric flux penetrates all surface of the sphere when theta is between 0 to pi and pi is between 0 to 2 pi. But this range is not all surface of the sphere. So electric flux doesn't penetrate all surface of the sphere. So when theta is between 0 and pi is between 0 and 2 pi, the surface area of sphere is 4 pi r square. At this case, the electric flux is 60 nanocoulomb. But this range is different from this. So we have to find the surface area when theta is 0 from between 0 and pi over 2, and pi is between 0 and pi over 2. So surface area is from 0 to pi over 2, from 0 to pi over 2, and r square sine theta d theta d phi. The lower limit and the upper limit are constant. We separated this integration. This is r square integral from 0 to pi over 2 d phi multiply integral from 0 to pi over 2 sine theta d theta. This is r square multiply pi over 2 multiply minus cosine theta from 0 to pi over 2. This is 1, and this is pi r square over 2. This is 4 pi r square multiply 1 over 8. So it means that this surface area is 1 over 8 of total surface area of sphere. So the answer is not 60 nanocoulomb penetrate this surface area pi r square over 2. Just 60 nanocoulomb multiply 1 over 8 nanocoulomb penetrate the surface area pi r square over 2. The answer is this is 7.5 nanocoulomb. This is the answer. The second question is rho is 26 centimeter and z is plus minus 26 centimeter. This is cylindrical coordinate. We can draw cylindrical coordinate. This is the y-axis, this is the x-axis, this is z-axis. This is 26 and 26. And this is 26. This is 26 and located the charge, and this is the pointer charge. Pointer charge is located at 0, 0, 0. So this electric field penetrates all surface of cylinder. So the answer is 60 nanocoulomb. This is the answer. So third question is z equals 26 centimeter. This is a plane at z is 26. Zero and 26. And this plane. So point charge is located in 0, 0, 0. The electric flux has two directions, the upward direction and downward direction. So total charge is 60 nanocoulomb. The electric flux toward upward is 30 nanocoulomb and downward is 30 nanocoulomb. that this z equal 26 plane is located at upward direction, so the answer is 30 nanocoulomb. This is the answer. The next example is find electric flux density at point P 2, minus 3,6 when source is distributed below. So I told you there are two methods to find electric flux density. The first is psi over A. Second is epsilon 0 electric field. I'll take a second method. First we find electric field and multiply epsilon 0 and to find electric flux density. So first is electric field by the point charge is q over 4 pi r square a r vector. So this is q over 4 pi r cubic r vector. So this is q over 4 pi magnitude r vector cubic r vector. So we have to find the r vector. R vector is the point at the source location is minus 2, 3,6, minus 2, 3,6, 3, minus 6. This is the source, and the 55 millicoulomb charge is located at minus 2, 3, minus 6, and the field is P is 2, minus 3,6, 2, minus 3,6. R vector is from source to field. This is R vector. R vector is we have this is Q and this is P. R vector is position vector of P minus position vector of Q. So this is 2ax vector minus 3ay vector plus 6az vector minus OQ vector is minus 2ax vector plus 3ay vector minus 6az vector. It becomes 4ax vector x vector and minus 6ay vector plus 12az vector. The magnitude of R vector is square root 4 square plus minus 6 square plus 12 square. This is square root 16 plus 36 plus 144. This is square root 196 and this is 14, right? 14 and 6, 5, 4, 1, 196, 14. So electric field is Q over 4 pi epsilon 0 r cubic r vector, and D vector is epsilon 0 E vector if the media is homogeneous media. So this is epsilon is deleted, the 4 pi r cubic q r vector. Q is 55 multiply 10 to the power minus 3 because milli is 10 to the power minus 3, and 4 pi multiply 14 square root 14 multiply 4 ax vector minus 6 ay vector plus 12 az vector. The unit is coulomb per square meter. This is the answer of question 1, and question 2 is the law is 20 millicoulomb per meter. The unit is millicoulomb per meter. This is line charge density. The line charge is located on the axis in free space. This is line charge This is z-axis. Line charge is z-axis. And we have the electric flux density at point P is 2, minus 3, 6. 2, minus 3, 6. The P. So we have already known electric field intensity by line charge. This is rho L over 2 pi epsilon 0 rho A rho vector. This is rho L over 2 pi epsilon 0 rho square rho vector. So electric flux density is epsilon 0 E vector. This is rho L over 2 pi rho square rho vector. Rho square is magnitude rho vector square. So we have to find the rho vector. The rho vector is, because this is the source is line charge at z direction. Rho vector is, this is 2, minus 3, 6. So rho vector must be represented by x component and y component, because this is the source is the g axis. So this is 2ax minus 3ay. For example, if the line charge is located x-axis, the rho vector is must be represented by y and z components, minus 3ay plus 6az. Right. So, but the question is, the line charge is located at the z-axis. Rho vector is this. So magnitude of rho vector is square root 2 square plus minus 3 square. This is square root 14. So the answer is electric flux density is rho L is 20 millicoulomb. 20 multiplied 10 to the power minus 3, and 2 pi multiply 14 and multiply 2ax vector minus 3ay vector. The unit is coulomb per meter square. This is the answer. So third question is, rho is 120 microcoulomb per meter square. Coulomb per meter square. So this rho is surface charge density. On the plane is z equal minus 5. This is we can draw the plane z equal minus 5. The z and z equal minus 5, and this plane is z equal minus 5 plane. The source is located on the plane z equal minus 5. Rho s is 120 microcoulomb per meter square. So we have to find the electric flux density 2, minus 3, 6, 2, minus 3, 6. So 2, minus 3, 6. We have to find electric flux density 2, minus 3, 6 p 2, minus 3, 6. So electric field by surface charge is not related to the distance. So this is rho s over 2 epsilon 0. The direction is this direction. This is the z direction, so az vector. So this is d vector is epsilon 0 e vector. So this is rho s over 2 az vector. So this is rho s is 120 multiplied 10 to the power minus 6 over 2 az vector. So this is 60 microcoulomb per meter square az vector. This is the answer of this question. So today we're talking about electric flux and electric flux density, and the relation between electric field and electric flux density, and calculate how to calculate electric flux density. Thanks for listening to this video, and see you next time. Bye bye.